Everything around you is built from atoms. Every breath you take, every drop of water, every cell in your body. Zoom in far enough and you reach a single atom. It is almost entirely empty space with a tiny dense nucleus at its heart. Crammed inside that nucleus are protons and neutrons. Around it, a blur of electrons races by. And one number changes everything, the count of protons. 1 proton is hydrogen, 2 helium, 6 carbon, 8 oxygen. Same particles, just different amounts. That is the whole periodic table hiding inside every atom. There are only about 90 naturally occurring elements. Line them up by their proton count and a hidden pattern appears. This is the periodic table. Every row is a period and every column is a group of elements that behave alike. On the far left sit the alkali metals, so reactive that a chunk of pure sodium explodes the instant it touches water. On the far right, the noble gases. Their shells are full, so they barely react with anything at all. From these few dozen building blocks, every single material you have ever touched is assembled. Atoms rarely stay alone. They bond, chasing a full outer shell of electrons. Sometimes they share. 2 atoms pool their electrons in a covalent bond, the glue that holds water together. Sometimes they steal. Sodium hands its lone outer electron to chlorine, and the two snap together as charged ions. Those ions stack into a rigid, repeating grid. That orderly lattice is a single crystal of table salt. Share or steal. Every material around you is just atoms, locked together by bonds. This is water. 2 hydrogens, 1 oxygen. But zoom in close, and you find a restless crowd of molecules in constant motion. They cling to each other with hydrogen bonds, forming and breaking billions of times every second. And every molecule is bent, a negative oxygen, 2 positive hydrogens. That tiny lopsided shape is why water behaves like nothing else. Add energy to matter and it transforms. The same particles, just moving faster. In a solid, particles lock into a rigid grid. They can only vibrate in place. Add heat and they break loose to slide and flow. Now it is a liquid. Add more and they fly apart completely, racing in every direction as a gas. Push even further and electrons tear free, creating plasma, the 4th state and the most common in the universe. In a chemical reaction, old bonds break and brand new ones form. The atoms are only rearranged, never destroyed. Take hydrogen and oxygen, on their own, 2 perfectly stable gases. Add a single spark, and their bonds tear apart, setting the atoms free. Instantly, they recombine into something new, water, and the leftover energy bursts out as heat and light. Break, rebuild, release. That same dance powers a candle, an engine, and every cell in your body. Why do reactions happen at all? 2 forces decide it: energy and entropy. Entropy is the universe's relentless drift toward disorder. A puff of perfume always spreads to fill the room. It never gathers back into the bottle. When a change lowers energy and raises disorder, it happens all on its own. But many reactions never truly finish. They settle into equilibrium, running forward and backward at the very same rate. A restless balance, endless motion with no net change. How do chemists count something as impossibly tiny as an atom? They use a unit called the mole. 1 mole is a fixed count of particles, 6.02 times 10 to the 23rd, Avogadro's number. That is 600 sextillion. A single spoonful of water holds more molecules than there are stars in the known universe. The mole lets us scale from invisible atoms all the way up to grams we can actually weigh on a balance. It is chemistry's bridge between the single atom and the laboratory bench. Acids and bases are opposites, and water keeps the score. An acid floods water with hydrogen ions. A base soaks them up. We track the balance with the pH scale. It runs from 0 to 14. Below 7 is acidic. Above 7 is basic, and 7 is perfectly neutral. But each step is 10 times stronger. Lemon juice is 100 times more acidic than your morning coffee. From battery acid to bleach, pH quietly governs the chemistry of water. One element stands above all the rest: carbon. Carbon is the ultimate connector. Every atom can form 4 strong bonds at once. So it links into chains, branches, and rings, building millions of different molecules. These carbon skeletons are the backbone of life itself. Proteins, DNA, fats, and sugars. One element, endless architecture. That is the whole field of organic chemistry. Reactions do not happen for free. They need a push to begin. That push is the activation energy. A hill the reactants must climb before anything can happen. Give them a spark or some heat, and they crest the top, then tumble down, releasing energy as they go. A catalyst lowers the entire hill, so the reaction runs far faster and is never used up itself. Your body is packed with them. Enzymes are catalysts that keep every cell alive. 2 last ideas tie all of chemistry together. Acids donate a proton, a single positive hydrogen. Bases accept one, mix them, and they neutralize each other. Redox is the other great exchange. One atom loses electrons while another gains them. Just remember, oil rig. Rust, batteries, fire, and the very breath in your lungs are all redox, quietly at work. Atoms, bonds, reactions, and energy, from a single proton to the entire material world. That is chemistry.